Welcome. Today we're going to look at some advanced settings within Prusa Slicer, and we're also going to compare that to some of the CAD files that we're going to be using. Hopefully this video will give you some understanding of orientating your parts, wall thickness in your CAD designs, the infill within your parts and changing that, how we can change text to better manipulate for Prusa Slicer, how we can change colors mid-print, create supports, and maybe how to tweak the time of a print. So we've got a few things we're going to look at today. I have Prusa Slicer open on the computer. I also have Inventor up with a couple of CAD files we're going to look at today. The first CAD file we're going to look at is this kind of wall stepping design with a shelf. I've designed these wall thicknesses here to be 0.02 thick, 0.04, 0.06, 0.08, and 100th hour 0.1 thick. And then we got about an 1/8 inch floor down here. So we're going to export that file for CAD as an STL so that we can bring that into Prusa, import that file, wall thickness, and it brought that file in. I like to just hit slice now right away, just see how things go with generic settings right off the bat. And we're using our generic 0.2 quality. I kind of use that for almost everything I print. If I'm looking for real good detail, I'll bring it down to 0.15 quality. I think only a handful of times in my life have I ever gone less than that for what we do. So I'm pretty much always 0.2 quality. We have a material at generic PLA for what we're doing, and just a 15% infill, which I usually step that up. But if we come into the wall thickness here, which is why I have this print right now, this 0.02 wall thickness is really only getting one layer of filament here wide. So it's not real strong, it's not working out real well. As we step up to 0.02, we are getting 2, or 0.04, we are getting 2 walls. And then we go up to 4 walls, 4 and 4. And that's because we have our settings set at 2 wall thicknesses on the perimeter. So what does that mean? If we go into our print settings tab for the first time, we got all kinds of stuff in here. Really, I typically only mess with 2 or 3 things in here. You can really play with quite a bit. I would suggest doing one change at a time and see what that change does, and that's a good way to learn what all these different settings are. But here's our vertical shells perimeters and our horizontal shells for the top and bottom layers of your part. We're going to mess with perimeters. If we go from 2 to 3 and then we re-slice it, you can see now it goes just like before, 1 layer because it's all it can fit in there, 2 layers, 4 layers, and then we can start to get an extra one in. It's supposed to do 3 and 3, but it can't fit them here, so it fit 1 extra. And then here we got 1, 2, 3, 1, 2, 3. So it did all 6 on this particular wall. Why are we looking at this wall thickness concept? Because a lot of times people will design a box, a cabinet, a shelf, a bracket, and they just choose a standard wall thickness, 1/4 inch thick. I don't know, maybe that's what the material is going to be, so you need 1/4 inch. Maybe you're just picking a number because you're not sure. And what can happen is you can have just extra material for what you don't necessarily need here. This 2-wall perimeter has infill going in to this dead space in here. If I change my infill to 5%, let's say, which is that one, I'm going to scroll down a little bit maybe. There we go. So that's our infill, and it's pretty much putting like no infill in there. If we go to 15%, you know, it's putting a little bit in there, it's fine. We can go heavy and make it real heavy in there if we want to, 40%. But that's just fill space in a wall. So if your wall doesn't have to be a 1/4 inch thick, you know, maybe you think about, or whatever, maybe you think about bringing that wall thickness down. So I think an 80 thou to 100 thou wall thickness is pretty good. 80 thou here is this one, and it's not putting any infill in there. It's going to be strong for what you're doing, saving material and not putting any infill in there. Not that you can't, but just thinking about design for wall thicknesses. So I'm going to go back down to a 15%. I'm going to come back over here and go to a 3%. perimeter setting and slice this again. And I would probably stick into one of these two wall thicknesses, 0.08 or 0.1. The next thing I want to look at is your infill here. We played with a little bit. We're going to come down farther to get to the inside of this particular part. So we're now at the inside layers, and it's doing this pattern here at a 15% infill. If I change that to, let's say, a 40%, I don't think I've ever printed 100% anything. In the end, this part is going to be super strong for what you're doing, interconnecting all these different weave patterns, but that's a 40% infill. Let's take a look at something here. We are at, let's go back to a 2-layer wall, 15% slice. Let's look at time. This particular part here is going to take 45 minutes to print. If we go back and put it to the 3 wall, 40% slice, it's now 54 minutes. So it's about 10 minutes longer to do those changes, which is not bad. Definitely doable time to strengthen this part up tremendously in what we're doing. So that's infill. We can come over here and change our infill pattern by choosing, instead of layers and perimeters, we can choose infill. And it's got the pattern right here. We can go instead of gyroid. We can choose any one of these. And we actually have examples of many of these different types in the back of the room by the 3D printer. So if you're wondering what cubic is, well, there's an example in the back of the room with various infill patterns. So go ahead and go look at that. Or we can just come here and hit slice, and there's cubic. And if we change it to aligned rectilinear, there's that one. And if we come down to adaptive, I mean, we can sit and click through all these and see what they do. We tend to use this one quite a bit, the gyroid. Honeycomb is one of the traditional ones that used to get used a lot. There's honeycomb. But we kind of lean to gyroid quite a bit. It's kind of the default one. It's a very, very strong infill pattern for what we're doing. So that's your different infill patterns. If you haven't figured out, you can grab this little sidebar on the right and drag it layer by layer and see what each layer is going to do. So let's come all the way down to the bottom. Here's first layer, and it's a full layer. Second layer is full. Third layer is full. Fourth layer is full. Fifth layer, we start to do the infill pattern. Well, can we change our top and bottom layers? We absolutely can. Back in print settings, layers and parameters. Right now it says bottom is doing 4 layers, top is doing 6 layers. Let's set them both to 3 and 3 just to see what that looks like. Slice. And now when we come down, 1, 2, 3, there's our infill. And here we've got 1, 2, 3, and we're at the top of the part. Let's see, 1, 2, 3, 4. That one did 4. 1, 2, 3, 4. Let's go see what print settings. So it's adding a 4th layer from a setting somewhere in here, which is fine. And there is our walls coming up. So far we've talked about wall thickness and how you can change the perimeters and how that might affect the infill of a wall from a box, as we saw here. We looked at top and bottom layers. How many solid layers do you want, or how many do you need? If you're trying to make a really strong part, then you probably have a lot of walls and a lot of floors and ceilings. We also looked at our infill, how we can change the percentage and the type of infill. And by doing the slice now, you can quickly and easily see what those look like. So the next part we're going to bring in, let's go new project. We're not going to save what we have here. Discard. Let's first go to the CAD. All right, so the next file is this here. We have just a little key tag type deal going on with some font on there. It's a pretty common thing. People put their name on something and want to extrude it. So let's go ahead and look at that. We're going to go back and forth to the CAD file a few times on this one. So we're going to export this. Go Goslings. Import. And slice it right away. So we're back to our standard settings of 2 per perimeters, 6 and 4 layers there, and our gyroid at 15% is our standard settings. And we can come in here and look at this part, and I designed it in CAD for the height to be just 2 layers. So we're going to look at that briefly, because sometimes if we're just trying to get letters on a key tag, you don't need this thing an 1/8 inch tall of letters. You just want them enough to be able to see those letters on there is one of the things. One of the other things that happens quite a bit is people choose a font that's not real easy to see. So let's go look at a couple of things here. Let's change our font on this to something that's like City Blueprint. Finish. Export that file. Actually, I'm going to make it go farther out too. So I went 16 thou was about 2 layers. About 8 thou is a layer-ish. So for every 8 thou, it's going to put another layer roughly in Prusa at 0.2 quality. So it's something to think about. But if we go, 100 thou out there, great. Let's look at how silly this looks. So import. I got one too many on there, that's fine. Slice. So now if we go look at this, this lettering is only 1 layer thick all the way around, so it's pretty weak. Plus it's way higher than it needs to. I mean, we're like 15 layers tall or something here, 10 layers tall of just the letters. Do we really need it to be that tall for what we're doing? So sometimes the choice of font can make your part print successful or unsuccessful. And then just the design, does it really need to be that tall of lettering? So let's go back and re-change that. So I'm going to undo to get that skinnier. I'm going to go back in and change this to an Arial. This time I'm going to go bold, make it even better on that front. Finish. This time I'm going to cut in. A lot of people like to cut in versus stick it out. So let's just see what that looks like for a difference. Personally, I usually prefer it going out, but everybody's design is their own. Whoops, Prusa. File import. So this time that part is going in and everything sticks out, and you go, well, it's kind of hard to see that. So let's come down, let's just take this top layer and change the color of it briefly just so we can see that. So now you can see that 2 layers down, if we go 1, 2, so there's our flat layer, and then it starts to do letters on top, more letters on top, so 2 layers above it, and we have that. And yeah, it's nice and clean on that top layer, but because of how the slicer will run around the edge of parts, you're going to kind of see the letters with stencils around them. So if you're okay with that, then that's what you're going to see with an cut-in lettering. But we can take that same lettering and send it out. Export CAD format. Slice. And we're going to come down here, get rid of that, and we'll make this a different color. So now you can see that the letters are sticking up on top of that surface. They're pretty thick in there, so they are definitely filling that better. We do have a little bit of infill going on the end because of the gap there. We're doing a 2 wall thickness on the part because it doesn't need to be real strong. If we come in here and change it from a 2 to a 3 and re-slice it, it's going to make it 3 everywhere, but now we don't necessarily have the infill on the end. It makes this little goofy pattern, I guess, so it's whatever you prefer for a look, but it had to fill that end in somehow, so whether it is wall or infill on that process. So you've kind of noticed that I was changing colors here visually to see when that pops as a layer. But when I actually do that, it's actually going to pause the print on the actual printer when it gets to that layer, and it's going to ask you to change filament by doing what we did. So you can actually make this print in 2 colors on the 3D printer and have the letters be a different color, which is pretty cool, by simply taking this to the layer you want the new color to be. So I want this layer to be the new color, and I'm going to hit the plus sign, and now we just created that at that point it's going to change filament and print the rest of the part, whether I did it there or way down here if I did it. Okay, so if I do it way down here, then right there it's going to start printing a new color all the way rest of the way through the part. Wherever it is I happen to put that. You can do multiple in the same print, I guess, but that's definitely an option to do. You need to keep to the same filament, so if you're printing in PLA, then you need to stay with PLA. You can't go from PLA to PETG mid-print. So you should be staying with whatever material it is you're using. Typically for us on these types of parts it'd be PLA. The other thing is you have to be in the classroom or at the printer when this goes to the filament change, because it's going to stay hot. It's going to be beeping in the back of the room saying, hey, something's going on, come read my screen. The screen says change filament. It'll walk you through those processes. If you're not in here and it goes to that process, it's going to sit and beep and stay hot until somebody's there to do it, and somebody else may or may not know what color or what you're trying to do with that print, so they may just cancel the print thinking something's wrong. So make sure you're going to be in the room for that. So if we look at this particular print, slice, this is a 35-minute print. It's towards the end, so theoretically, you know, about a half hour in, it's going to ask you to change filament. So make sure that you are there for that. We can actually look at these settings over here, and it says at the 35 or 34 minute mark duration, 34 minutes, it's going to ask for the color change, roughly. So if you're not going to be in the room at that time, don't start your print or wait to run it at a different time. So that's definitely a neat feature that you can do color changes mid-print. We can also do multiple parts. Now I do want to caution many times how big of parts you print. Yes, we can print all the way out to the white line on the Prusas, but in my experience I've found the bigger the part, the more chance of things not printing correctly. So it's just something to keep in mind. If you were to fill this bed with a whole bunch of parts, they may or may not print. So we're going to take this part and we're going to go copy, and then we're going to go paste, and we could, you know, print 2 of those parts. And when we slice it, it now does the work, saves the settings, and does 2 of them. Takes an hour 10. We could come in here and go paste, paste, and set them kind of centered on the bed. Now we got 4 of them. So that's, you know, nice that we can batch up and do multiples, but now when it goes for the color change, instead of the 35-minute mark, it's going to be at the 2 hour and 14-minute mark because we're doing 4 at a time. So 2 hours and 14 minutes later, it's going to be asking for a color change on this particular print because we're running multiple with a color change. All right, let's look at the last part I want to bring in. That's going to be this part here. I want to look at a couple of different things about this advanced piece here. This happens to be a marble chute for a test project we were working on, 3D printed, had a trap door on it, was held with some rods up in the air. So we've already got this file designed. We're going to import that part, and it brings the part in. I'm going to slice it right away just to look at some settings and times and whatever. I'm going to run that all the way up. And this is an 11.5-hour print about. So this is a pretty long one. It automatically put it down with the funnel side down, which is, you know, okay. But if we inspect this part, is this the best orientation for this part to be printing? So if we look at the CAD file, it's a little bit easier to look at this part. I would say that is not the correct orientation. The way it's designed to have all these draft angles and such, it should be printed from the other direction. And there's technically this flat right there. which is maybe a design flaw, one could argue, but that flat is not going to print well upside down. So that flat, as you can see, is going to have an issue unless we turn supports on. So you say, okay, let's just do supports. All right, that's easy enough. We can come over here to supports. We can say support on the build plate only. Slice, and it does nothing. Why does it do nothing? Because the build plate is not underneath of that. You have material. So we have to come over here and do everywhere, slice. And now it puts supports on, but they're connected to the part. It adds a half hour to the print time for those supports, and you've got to clean them up later. So yes, we can print this part like this. It will come out successfully, but it uses more plastic, takes more time, and may not look as good in the end because those supports are attaching a little bit to the part. So I would suggest flipping this part. I like to use this place on face when I'm rotating stuff so I don't mess up grabbing at a random angle. So I do rotate on face. It gives me some faces to grab. I want that one. And then we've rotated it, so now we can slice. And remember, we still have supports turned on everywhere, so it says, okay, we could still run some supports into those areas. But if I turn them off, I don't think I really need those supports anymore with the way this designed, because we have a draft angle here, we have a nice clean angle right there, those holes going in are supported at some nice angles. The only thing that might be a little iffy is this area right here when it prints that top, but the way this part's designed, that is not a crucial area, so if it messes up on a layer there while it gets that roof, it'll be okay. This part here is now 11 hours and 5 minutes on that print. We wanted this piece to be pretty strong when we did it, so I'm willing to bet I was 3 perimeters. I was probably 25% slice. So this part's actually going to be closer to 15 hours long to print this particular one. We're only going to do one at a time. There is a chance of anything going this long to fail, so we are taking a little bit of a risk on this long of a print, but that would be how we did it. So in this particular one, we looked at how to rotate using the faces, and we looked a little bit at the supports of a part, which you can use if needed, depending on the part that you are trying to print. So often people will just, the part came in however when they brought it in from Inventor, and they'll be like, oh yeah, let's just print like that. Well, this doesn't make any sense to print a part like this if this is how it came in from Inventor. You go, well, I can just turn on supports, everywhere and slice it, and yeah, sure you can, but look at this thing. It's trying to support everywhere. On this part, it's now a 22-hour long print. Like, this just doesn't make any sense. So make sure when you're bringing your parts in, you actually look at the proper way of what makes sense to orient that part. I know this was a little bit longer video. We covered a bunch of different things in this particular video, so hopefully this helps you to improve your print qualities, improve strength of your parts, look at how you're designing those parts to be the right thicknesses, the right materials, maybe speeding up or slowing down prints as needed. Hopefully some of you play with the multicolor at some point when it makes sense. If you're going to be in the room for those changes, it's always a fun next step for simple prints is just to change the color, and so on. So happy printing.